Alright, and welcome to this short video. We're going to go over the first part of IGCSE Marine Science 5.1, and we're going to learn about the language of ecology, which is going to come very handy in the very next videos where we talk about the different ecosystem types. So, as always, these videos here are free, and they're made for my class, but if anyone else could use them, you're more than welcome, and any mistakes here, and mine alone, and does in no way reflect on Cambridge. Let's go. If you're also doing biology, we are going to go over things here, which also covers a little bit of the chapter 1 in the IGCSE syllabus, and quite a lot in chapter 18 in the biology syllabus. So there's quite a little crossover here if you're one of those doing both syllabuses. So the first thing we need to define here is what species are. And we might have an intuitive understanding of it, but in biology, and therefore also here in marine science, species are individuals that can reproduce to produce fertile offspring. So, for example, bottlenose dolphins can produce new bottlenose dolphins, but if a bottlenose dolphin and, let's say, a sea otter were dating, there wouldn't be any offspring for very obvious reasons. Now, sometimes species can look almost the same and not be the same species. Or in other cases, you can have, for example, if you look at dogs on terrestrial land, a big difference between a German Shepherd and a Chihuahua, but there are in fact the same species and they can produce offspring. There are a few examples when different species can produce offspring. A wolfin, for example, is a mating of a common dolphin, bottlenose dolphin, with a faced killer whale. So there are, of course, exceptions to the rules, but in general, when we talk about species, it's important to remember it's organisms who can produce fertile offspring. In biology, and therefore also in marine science, a population is a quite strict definition. A population is a number of organisms that belong to the same species living in a specific area at the same time. So all these penguins here, they belong to the same population as they are there at the same time, at the same place, and they are the same species. So we'll take it up one more step. We have an organism. That organism belongs to a species. That species can live in a population, as we talked about earlier. That population can then be part of a community. Now, the word community might mean something different when we just use it in normal English, but in scientific English, a community is definition of all the population of all the different species in a specific area in a specific time. So, for example, in my coral reef, we might have a community of like 50, 60, 70 different species living in different populations in the same community. This is different from population because population is just one species, where a community is more than one species. And as we're going to talk later about the ecosystem, this is different from the ecosystem because the ecosystem also includes the non-living components and the different biotics and abiotic factors. So there's a lot to keep track on here, so it's important to know how to separate population from community from ecosystem. The habitat is the physical area that an organism lives in and where it interacts with its environment and other organisms. So, for example, a habitat for my clownfish could be the coral reef area, and a habitat for my common crab could be my sandy beach. Now, it's important not to confuse the habitat with the environment. The environment is the sum of all the factors that surrounds an organism and affects its life. And we tend to block these into two: abiotic factors and biotic factors. Abiotic factors are non-living things. So in the marine environment, for example, this can be salinity, it can be pressure. There's a big difference if you live at 500 meters right at the surface. Light, especially for our producers doing photoautotrophic um, production. Oxygen concentration, of course, for anyone doing respiration. Temperature will have a huge effect. Wind speed, CO2 concentration, and thereby also pH and acidity, and currents, and there are quite a few others. In general, abiotic factors are all the things that are non-living that affects the organism we're talking about. Biotic factors are living things. It can be food supply. Are there any algae to eat if you're a herbivore? Are there any prey to eat if you're a carnivore? Disease and parasites, other organisms affecting your health. It can be competition, competition for mates, competition for food, competition for a substrate, where to sit, competition for light, competition for pretty much all the resources that are important. And last but not least, because that's the one we see a lot in Discovery, predation. If there's someone else who wants to eat you, for example, if you are a fish and a shark comes by, well, that is a biotic factor that will have a huge effect on you and your life cycle. So it's important to look at these and think about many of those abiotic factors when we are doing any kind of exam paper, when they ask about things we wish to control in an experiment. For example, you have a fish tank. We usually want to be able to control all these abiotic factors to keep those constant, so we only have one variable. So this is also a good checklist for all these questions in an exam setting. We finally get to the last definition, ecosystem, which is one we are going to use a lot in the rest of this chapter. So an ecosystem are all the populations living there and all the different biotic and abiotic factors affecting each other. So it's all the organisms and their environment together. So for example, my coral reef is an ecosystem. That's a big one. On the other hand, the very small biospheres we made in marine class is also an ecosystem, just a very small one. Ecosystems are dynamic entries. It's not like, if you are a coral reef, you're not affected by anything outside. There can, of course, be other ecosystems affecting you, or if you are a ecosystem, saying a sandy beach, of course you can be affected by other systems. So it's not static. Sizes of populations in our ecosystem can, of course, change over time, and they usually do. And they can do that pretty much due to an antibiotic or abiotic factor. So, for example, if I have my marine algae and I suddenly have an upwelling with nutrients, there'll be more nutrients. This will, of course, increase my amount of microalgae. A classical example of this is a predator-prey cycle, as I try to show here, which basically say as if you have a population of prey that grows, let's say for example that I have an increase in my herrings, then my predators, my tunas who eat the herrings, will then also start to increase because there becomes more food for the predators. As they become more predators, well then the amount of prey will go down again. As the amount of prey falls, there will be less food for the predators, so the predator population will fall. This again will affect our population of prey, so they will increase again. Now, this is a classical example used in biology, and it is a little simplified because quite often there'll be more factors playing into this. But it's a good idea to know that there is this kind of predator-prey cycle, and we will be talking about it also later, where the amount of food available kind of determines how large our population of predators can become. It also shows that the amount of predators can help regulate the amount of population in the prey population. So as always in Cambridge, there's a lot of new keywords to work with, and the most important one here is, of course, species. Species is a group of organisms able to produce a fertile offspring. If you have more of one member of the same species, they can be together in a population. that population can be part of a community. That community is affected by the environment around it, and everything can then be part of an ecosystem. And in the environment and the ecosystem, everything is affected by both abiotic and biotic factors. Spend a little time reviewing these keywords, and everything else in this chapter will become just a little easier. See you soon, and thanks for hanging by.